Okay.
This meeting is being recorded.
All right. So welcome everyone to the first kickoff meeting for the open meetings for the ILLIXR Consortium. I'm Sarita Arbe. I'm a professor at the University of Illinois, and Muhammad Huzaifa is the co-chair of the ILLIXR Consortium, and with me, and between him and me, we will be covering just an introduction to ILLIXR and the consortium in the beginning, and then open it up for questions. But of course, as always, please feel free to interrupt. Before I go ahead into ILLIXR, I want to acknowledge a very large group of people, both students at Illinois and developers. The development was mostly done by this very large list of students, and then a lot of external consultations with many people, including our executive committee and advisory board that you will hear about later. But I want to give particular thanks to the founding consortium members, Meta Reality Labs, Micron, and NVIDIA. They've been with us. Many of these people have been with us from the beginning, and our founding sponsor, the Ada Research Center, which is a DARPA and SRC-sponsored JUMP Center. So I have a couple of the key people who've been big supporters from the beginning from these companies. And before we kick off the details of ILLIXR, I'd like to hand it off to them for just a few words. So Matt Horsnell from ARM.
Hi, Sarita. Yeah, thanks. Matt Horsnell, I lead the architecture research group at ARM. Really excited to be here for the consortium launch. As Sarita mentioned, we've been around on the ILLIXR project for a number of years now, and the work that's happened to date has been fantastic. The research is really exciting, I think, and we're at a point now where I'm excited to see what the consortium can bring to this. Academics and industry coming together around this ILLIXR platform hopefully can help us push XR technologies forward. So congratulations, Sarita and team, for getting to this point and building the momentum around the platform and the consortium. And yeah, super excited to see where this leads to.
Thank you so much, Matt. And then Amin, and both Matt and Amin, ARM and Micron are sponsors of the JUMP Center. So that's been huge for us. Yeah, Amin, go ahead.
Yeah, and I'd like to echo the comments that Matt made. Again, it's been fantastic to watch the momentum around ILLIXR grow, and I'm very excited to see the number of people here who are showing excitement for the exact same thing that I'm excited about. It's been fantastic to watch the platform grow. It's been fantastic to watch the research that's grown around it, and I'm very excited to see where the consortium decides to take this next in terms of advancing the state of the art with XR. So very excited about this. Again, I echo the same congratulations, Sarita, to you and the team for getting to this point.
Thank you. Thanks so much. Thanks a lot for your support throughout. Okay, so in the interest of time, we will get started. So we are all here because we do believe that extended reality, or XR, including virtual, augmented, and mixed reality, is going to change the world, right? It's going to transform almost everything that humans do. It's going to be the next big computing interface. But at the same time, there is an orders of magnitude gap in power, performance, and quality of experience between current systems, what we've been able to deliver today, and what we desire for a fully immersive XR experience. So for systems researchers and computer architects like myself, this is a great opportunity and a challenge to bring to bear our expertise to make these systems happen. But at the same time, when we started this work, we realized that this is a great opportunity, but there's just so much difficulty in getting this type of work done. So for example, XR requires diverse expertise. We need to bring together people in graphics, vision, audio, video, optics, haptics, and so on. Because of this large gap in power, performance, and quality of experience, we believe that the future XR systems need to employ cross-layer system co-design, including hardware, compiler, OS, and algorithm co-design. The goodness metrics of these systems rely on end-to-end human perception, and there's many user-driven, end-to-end QoE-driven metrics that are very complex. And in fact, this itself is a research area. So very difficult to do research in this area. But the biggest thing that stumped us when we started was that the systems were closed and there were few participants. So while we were excited about research here, there were no open reference systems or benchmark suites that could push our work, that could motivate our work or drive our work. So seeing this very large barrier to entry for open R&D, we decided to devote ourselves to first deal with this question of how can we democratize XR systems, research, development, and benchmarking. So that is the history of, a very brief history of how ILLIXR was born. So ILLIXR, originally stood for Illinois Extended Reality Testbed, but we'd really like to take this beyond Illinois, and that's where the consortium comes in. So today, ILLIXR is an open source full system XR testbed. It has state-of-the-art XR components with a modular runtime. It's compatible with OpenXR, which is a standard for the interface between the applications and the XR device. And we've used it already for a fairly extensive characterization of XR systems, and we are using it for a large number of research projects. So before we go ahead and talk more about ILLIXR and why the consortium, I just want to show you a few demos to show you that this is, what we already have is real, but we need to take it much further. So this is a very brief demo of how we use ILLIXR day to day in a fairly simple setting. Josefa actually is walking around our lab here in this. Can people see this? Is it smooth? I don't know what Zoom and the internet are doing. Josefa, is this smooth for you?
No, it's not smooth. That's the thing. Too much to expect from Zoom.
Okay,
but
right.
I think we get the idea.
Yeah. So this does work, and the tracking is pretty smooth on my screen. So Josefa walking around in our lab with a camera, a student sitting on a desktop with a monitor, no fancy headset or anything. Just a monitor for this one, the regular LCD monitor, and this is the virtual space that Josefa is traversing with the cartoon of the headset showing where the headset is. And up here is the pixels that ILLIXR is putting out so that we can see what's happening with whatever research we are doing, trying to quickly prototype our system. There's a debug window here that puts out a lot of information that we can use to help do our research. But then if you want to have a more immersive experience, ILLIXR now runs on the North Star headset. And so here we have a very innovative system where ILLIXR is running on this PC that Jeffrey, one of my students, is rolling around while Joseph enjoys this experience on the right. So again, if it's not smooth on your screen, trust me, it is smooth on mine. So Jeffrey's walking around this, using the Sponza application, traversing through a castle, and you can see the rendering is pretty good. The tracking is pretty good. Sorry, Joseph is walking around and Jeffrey's rolling around, rolling ILLIXR behind him. So this is a fully open source system, end-to-end, running on this PC that we can, measure all sorts of things. You'll see that later, frame rates, motion to photon latency, whatever you want to measure can be measured because it's completely open source end-to-end with the North Star headset serving as the display. Okay. So then, well, if Joseph wanted to, not have Jeffrey, not be dependent on Jeffrey walking him around, now we have ILLIXR running on this backpack PC that HP makes. So in the backpack, there's a PC with a battery, and Joseph is walking around enjoying the same experience by himself. Okay, so this is, so ILLIXR works, it's real. We've done a lot, but there is a lot more to be done. And so that's where this consortium comes in. So, we have a core group of industry and academic partners already, and we're talking to several more, several of you I know in the audience have indicated you want to join. And so we're looking forward to that. So the goals of the consortium are threefold. So although we've done a lot of work on ILLIXR, we would like to elevate this to a reference open source testbed. Build on this with ILLIXR as the foundation, create an open source testbed that the community can agree on for furthering or democratizing research, development, and benchmarking of XR systems. So this reference testbed would have state-of-the-art components and well-defined interfaces and a modular and extensible runtime, lots of telemetry, and so on. We also would like the consortium to develop a benchmarking methodology that the community can agree on. So what are the applications that people should use for benchmarking, be it for research, be it for industrial benchmarking? What are the data sets that should be used? What are the system configurations that we want to use for this benchmarking? And what are the metrics to report? And then finally, we would like to build an XR systems research and development community. This is a very broad and fragmented community. We would like to bring them all together, and these weekly meetings are also an attempt to do that. So I'm also happy that ILLIXR is now supported by an NSF-sized community research infrastructure program. So it's nice to get that blessing. NSF would like us to make this a community research infrastructure as well, which again, we're trying to do through this consortium. So that's sort of a brief summary and introduction of the scope of our activities. I will pass this on to Josefa to do a little bit of a deeper dive on ILLIXR, but we don't want to use up this whole time talking. So Josefa will give the description of ILLIXR and then very briefly say what it's capable of evaluating, the implications we've seen so far, what's the ongoing research that we are doing, what's the ongoing work on the ILLIXR testbed, and then briefly I will come back and summarize the consortium organization and goals, and then we'll open it up. But again, please do put messages on the chat or interrupt to ask questions. So Josefa?
Yep, thank you, Sarita. Before I begin, as Sarita said, this is meant to be just a high-level overview of what the ILLIXR system looks like and the results that we have gotten. If you want more details, we actually do have a longer PowerPoint presentation on illixr.org. Okay, so this schematic, Sarita, can you see the PowerPoint?
Yeah, it's
okay, yeah. So this schematic basically shows what the entire system looks like when you're running applications. So you have applications at the top, some type of XR application, and we assume that those would be written using the OpenXR interface. We leverage the awesome open source Monado project as our OpenXR implementation, and then all of the information from the application, requests from the application, they get piped down to ILLIXR, which is a set of pipelines. So the perception pipeline, which deals with what the environment looks like, what the user is doing, where they are. The visual pipeline, which is responsible for generating the pixels that will show up on the screen, and the audio pipeline that is responsible for generating the audio that the user will hear. And then all three of these pipelines come together using ILLIXR's communication interface and runtime. And then all of this runs on top of some type of desktop or mobile device. So I'll quickly go through the individual components in the three pipelines. First, in the perception pipeline, we have interfaces and implementations for sensors such as cameras and inertial measurement units. We have visual inertial odometry, which is more commonly or colloquially known as head tracking, which provides the pose of the user. And so the pose is both the position and the orientation of the person's head. And in this picture here, you can see the different points that are being tracked in the image to determine the pose of the user. But VIO is slow. It usually runs at camera frame rate, which is 10 to 20 to 30 frames per second. Humans can rotate their heads much faster than that. And so you need IMUs to keep track of the fast motion and provide faster high frequency pose estimates. And then for quite a few things that happen in the pipeline, you don't only need to know where the user is right now, you actually need to know where they will be at some time point in the future. This is usually when frames would be generated or when audio will be presented to the user. So we have a pose predictor that extrapolates the current pose to a given future timestamp. We also have scene reconstruction, which uses a depth camera to build a 3D map of the world. So this picture that you see here is actually a 3D reconstruction. And then we also have eye tracking, which assumes that you have inward-facing eye cameras, segments the image into the pupil, iris, sclera, and so on, and then uses a geometric model to figure out the gaze of the user. And then a lot or most of this information is passed on to the visual pipeline, which takes input frames from the application and then the pose of the user, etc., to generate the pixels that will show up on the screen. The first component in this pipeline is called asynchronous reprojection, or more commonly known as time warp, which accounts for head movements that occur between the time you start rendering and you finish rendering. And this is a very important component for minimizing the motion to photon latency, which is the latency between the time a user moves their head and the corresponding photons entering their eyes. The lenses that are used in modern wearables, XR wearables, have these lenses which are pretty curved and cause a lot of distortion. So you actually have to correct for that distortion. And we have a component that corrects for both geometric distortions and chromatic aberrations. And then finally, we have a component for computational holography, which assumes that in the future, if you want displays that can actually present multiple focal planes to the user, you actually need to generate some type of pixel mask that represents these different focal planes. And so that is the responsibility of the computational holography component. And then finally, we have the audio pipeline, which has two components. The first one is audio encoding, which assumes you will have multiple individual sound sources, and it encodes them into a format called higher order ambisonics, which is a standard format for representing spatial audio. And then we have the audio playback component, which actually manipulates the higher order ambisonic sound field based on the user's pose, and then actually performs binauralization to map the virtual sound field onto the physical speakers, which are typically just headphones in XR devices. But XR is not just a collection of these components sitting in isolation. It is a system in which all of these components are working together. And so if we look at how these components interact, we have an IMU, which is running at some high frequency, and we have a camera running in parallel at some lower frequency. And then the VIO, or the head tracking component, takes inputs from both the IMU and the camera. You will see that there's two different types of arrows here. The solid arrow denotes a synchronous dependency. So what that means is every time the camera runs, VIO also has to run. The dash arrow represents an asynchronous dependency, which means that VIO doesn't have to wait for the IMU. It can just get whatever the latest IMU value is. We have an IMU integrator, which takes inputs from the IMU and VIO. We have eye tracking running at some frequency. There's scene reconstruction. And then all of these feed into the application, which will see where the user is, what the user's surroundings look like to generate frames. The frames then get passed on to the reprojection component. And this one component, reprojection, also does the lens distortion and chromatic aberration correction. And then that finally gets passed on to hologram, which generates the phase mask for these holographic displays. And then in parallel, we can have audio encoding and audio playback running. So as you can see, there's a lot of components here. They're running at different frequencies. There are different types of dependencies between them. Some are synchronous, some are asynchronous. And there are different quality of experience metrics for the visual pipeline, for the audio pipeline, for perception, and so on. And so the ILLIXR runtime tries to manage all of this complexity. For plugins, we have a modular and flexible architecture, which maps each component to a separate plugin that can be separately compiled. And then at runtime, they are dynamically loaded. So the nice thing with this approach is you can develop components just by themselves. And as long as you conform with the interface, you can just load a plugin at runtime. And so this allows very easy swapping and addition of new components, and then also the changing of implementations, right? If you have one SLAM implementation and you want to change it for the other one, our architecture allows you to do that very easily. And in terms of communication, we use a publish-subscribe model, which allows you to publish data on named event streams, and then you can read data from these event streams either synchronously or asynchronously, depending upon what type of dependency you have. And then the communication is actually implemented using a shared memory implementation, which eliminates copies, and so ultimately gives you quite a bit of efficiency while also giving you a reasonable amount of flexibility. And coming to the applications now, there's two ways in which you can write applications for ILLIXR. One of them is that you can just directly interface to ILLIXR. And this is the sort of approach people used to take, but then there was a lot of fragmentation in the ecosystem. Now we can actually use OpenXR. So we use Monado, which is an open source project, which provides an implementation of the OpenXR specification. And then you can have any type of game engine that can interface with Monado. Currently, we have only experimented with Godot, but recently Unreal has released OpenXR support, and we're expecting Unity will too on Linux in the future. And when the system is running, we actually collect quite a bit of data that will help you analyze the system. This includes motion to photon latency, 2 types of image quality metrics, such as SSIM and FLIP, and then a lot of extensive telemetries for frame rates, power, execution time, and so on, including per component metrics, such as the quality of your pose and so on. And so this is a list of all of the components that exist in ILLIXR today. As you can see, for several components, we have more than one implementation, and then the implementations span different programming languages. And we run on 2 different types of systems so far. So a big beefy desktop machine, if you want to see if you had a lot of resources, how would the system perform? But we can also run on an embedded Jetson Xavier development board, which has a significantly lower TDP. And then you can see if you had a constrained system, how will the system run? Okay, so now that we had the system, we actually ran quite a few experiments and analyzed the results in a lot of detail, which gave us frame rates, execution times, the variability in execution times, the distribution of CPU time breakdown among the different components, how much power was being consumed, what the power's breakdown was among the different hardware components, what the final quality was, motion to photon latency, how often you violated the motion to photon latency constraints, and the final image quality metrics. And these are the first published performance power QoE numbers for an end-to-end XR system. And using these results, we got a lot of implications for system designers and hardware architects, such as the diversity of compute and memory primitives, needing shared or programmable hardware, and so on, which overall tells us that ILLIXR provides a rich playground for system researchers to experiment with and innovate with. And it enables our goal of QoE-driven end-to-end hardware software algorithm co-designed systems research. And again, if you want more details on the result and the implications, they are on the more detailed PPT on illixr.org. And now currently using this system, we actually have quite a few research projects in the pipeline, including if you want to build specialized hardware, how do you automatically select and generate this hardware? Once you have these accelerators, how do they communicate with each other? You have a lot of heterogeneous parallelism in ILLIXR. How do you represent that in compiler or software IRs? There's a lot of opportunities for performing approximations in the entire system, but how do you perform approximations in a disciplined way? How do you co-design components and hardware? You have to perform scheduling. You can, we are looking into offloading compute from the edge device to edge servers or the cloud. We're looking at on-sensor computing, new metrics for XR, and then also some innovations in XR algorithms themselves. And we're also happy to say that there actually has already been a published work that uses ILLIXR and looks at eye tracking plus holograms. And this was published recently in Micro 2021.
And some of the authors are on the call. So.
Oh, that's great to know. Awesome. So that was the research side. We're also doing a lot of work on the testbed side. We're adding new components. So currently reprojection only handles rotations. We're looking into adding spatial reprojection as well. We actually already have this component. We're just working on integrating it. We're looking at hand tracking, and we recently started looking at foveated rendering as part of ILLIXR. We're looking at adding capabilities to offload components and then stream data to a server and get it back, and also enable multi-party XR. This is a collaborative project with Connect Arena, and we will actually hear a lot more about this in next week's talk. We are also expanding the platforms that ILLIXR runs on. Currently, it's only Linux. We are working on adding support for Android, and we will hopefully be releasing a Docker image in just a few days or a week or so. So most people, question?
No,
Oh, I
this
think,
is-
yeah,
yeah.
Ketan, I think you unmuted yourself by accident.
There
Okay,
is
yeah,
a
so
question on chat, but we'll take it as soon as it's
Sorry.
okay, so yeah, so we'll be hopefully releasing a Docker image soon, and then we're also looking into creating our own XR specific data sets and applications. And then of course, there's always this feedback loop from the testbed to the research and then back from the research to the testbed. Okay, now I will hand it back to Sarita, who will talk more about the consortium, its goals, and how it is organized.
Yeah, so there's a question on chat. So the question is from Rajru Ghosh. Great work. Does the spatial audio component support 6 degrees of freedom movement for both source and listener?
For listener, yes. Source would require re-encoding every single time, because when you're performing ambisonic encoding, you actually need to provide both the distance and the orientation of the source with respect to the listener. So if it's a moving source, you need to re-encode the ambisonic field, but not for the listener, because that's the nice thing about an ambisonics field. It's a mathematical representation, so you can rotate and zoom however you wish once you have the field.
Does that answer your question, Raju?
Thanks a lot. Yeah, that answers the question.
Okay, great. I'm not going to go into too much detail about the organizational aspects of the consortium. It's all on the ILLIXR.org website. But the goals are that, again, that we want to have a reference open source testbed that we can all use for research, for development in industry, as well as for benchmarking. And so what this means is we all need to come to a consensus on what components to support, what types of implementations. As Josefa said, we want to be able to support multiple implementations of different components. But for that, we need to be very clear about what the interfaces are. And there's no real consensus in the industry. So if you look at different SLAM codes out there, integrating them in an end-to-end system takes a while because they all assume different interfaces. So we'd like to have a consensus on that. We'd like to have a consensus on the runtime. So, we've done a lot of work to make sure that the ILLIXRs, and by runtime, I mean the thing that's scheduling and orchestrating, doing resource management, ensuring that the dependencies are maintained, etc. That the runtime is modular and extensible. You can easily plug and play with different implementations of different components and so on. And then lots of telemetry. What types of metrics do we want to support? What types of observations we want from the system? And then again, the benchmarking methodology, as I said, and what applications, data sets, system configurations, metrics, etc. Get the community to come to a consensus on some of this, and then build the community, right? And so I hope you will continue to join these weekly open meetings and spread the word around. But the key point I want to make in this segment, and just not take too long on this, is that we'd like these meetings to essentially aggregate into subsets of people that have working groups, right? That form working groups on various topics. So right now on the website, you will see a whole sort of governance structure for ILLIXR, including an executive committee and how we will orchestrate these working groups. There's an advisory board to provide overall strategic vision, and then how we want to form these working groups. So it's this, or organizationally, we anticipate a very lightweight, very open community. I mean, very lightweight requirements for people to join, very heavyweight contributions, but an open community that is very welcoming. If you're interested in XR systems, please join. Please get involved. Joining the consortium itself, again, is a fairly lightweight process. Everything is in the open. And yeah, so please contact us if you have more questions beyond what's already on the website. So for the working groups per se, we have certain ideas. Yeah, Abhishek, you have a question?
Yeah, I have one question, especially there was one in the previous slide, there was the non-members
Yeah.
And there was something called lightweight approval. So what do you mean by lightweight approval? So
Well, just send us an email and say you're interested, right? And as long as you're legit, I mean, we don't want people to come and railroad the stuff, just
all
bad
right.
people coming in. Yeah. So we just want to have, a little bit of control that people coming in are legitimate, interested parties. That's all.
Right. Thank you.
Right. But yeah. But for people who would share the working groups and so on, of course, there's a whole another process for that. And at this point, we just want to be welcoming. We think there's just so much work to be done that we don't want, unnecessary organizational bureaucracy to get in the way.
Yeah, right. So may I follow up with you or like Muhammad later on through email on this one?
Yeah, definitely. Yeah.
Thanks.
Yeah, definitely. So some of the topics that we have listed here, and they're on our website with more detail about what we really mean by these, sort of reflect what we've been saying all along, right? So working group on metrics, and these will eventually also, divide up into subtopics, because there's a lot of work on metrics, interfaces, the various components, VIO and scene reconstruction and eye tracking, etc. How do you do computation offload? We have an initial implementation, but there's a lot of work to be done here. Distributed XR, this will be the topic of next time. Configurations and benchmark reporting, applications, data set, and infrastructure related issues. Right now, how do we monitor development, etc. And then a whole bunch of work on research related things. So again, there's lots of work to be done, lots of ideas. A lot of this will happen based on the people involved. So do get in touch with us separately, or I'm going to open this to discussion in just a second, and let's talk. So again, next week, Anthony Rowe from CMU, he's been leading a very exciting project called Arena, which is essentially a distributed XR system, and he'll talk about it. And we are working on how we would integrate this with ILLIXR. So this is next week. So yeah, so this is wrapping up the formal presentation part, and I'd like to open this up to the audience. Thoughts, questions? I'd love for people to say a little bit about themselves, and what's particularly interesting here to them. That's fine too. So yeah, I'd like to open this up.
Hi, so may I start?
Yeah, please do.
Right. Okay, so a little bit of introduction. So I am a PhD student at the University of Helsinki, soon to be postdoc at the University of Oulu. And I have been hired by the University of Oulu to bridge the research. We have two research groups at the University of Oulu, Perception Group led by Stephen Lavelle, and then we have a networking group led by another professor. And I've been asked to become a bridge between two research groups. Right now they are working separately. They are not talking to each other. So I was particularly interested in distributed XR, one of the working groups which I saw. So I was wondering if the work has already been started, and if I could find more information, who are involved and what direction this working group is taking. That would be really great.
Yeah.
But, for the next 13 months, Academy of Finland is sponsoring me to do only this work. So
awesome. Fantastic. So first of all, welcome. Steve Laval is the reason that ILLIXR started in some sense, because he was the first person who encouraged us to do this work and helped us understand the space. So I'm really glad, and he's on our advisory board. So I'm really glad to see you here. Yeah, so for the distributed XR, next week will be all about that. It's still in the ILLIXR, the integration of that with ILLIXR is still in planning phases. So this is a great time to jump in and contribute, collaborate. Yeah, so we'll have a more detailed conversation next week.
Right, thank you. And I will follow up with you, because my supervisor is really interested in this. So.
Yeah, great,
right.
Fantastic. Okay, Other questions, thoughts, comments?
I thought I'll introduce myself.
Yeah, please do.
Yeah.
Yeah, I was waiting to call on you at the next.
Okay.
Yeah.
Sure. I'm Jacob Bonnekrantz. I work for Collabora. We're behind the Monado project. I guess I can say the lead, tech lead, or whatever, architect behind it. Yeah, and we're working on making Monado a completely open XR runtime. So yeah.
Yeah.
So,
And yeah. Go ahead,
yeah.
Jacob.
And we also we have some various projects going on that we probably should collaborate on, especially hand tracking. So, and SLAM.
Yeah, and so Jacob is also one of the people without whom ILLIXR would not exist in the form that it is today, because as we've said, we use the Monado implementation, and hoping that that the two projects can leverage each other, increasingly as
Yep.
fun.
Yeah, and yeah, finding interfaces will be really hard between component. I think the only common interface I found between the various SLAM libraries is UROC, and that's not really real time, unfortunately. So
Yeah. So we support now many more data sets than UROC. There's one from Virginia VCU. There's one from Eta-Haiti PH3D. There's many data sets that we support now. It took a while for our students to get them interfaced, but not that long, just because we tried to build our VIO interfaces from the ground up for exactly this reason, so that we could mix and match things. And in fact, one of the things that one of our students is working on is to build an abstraction so that this type of interfacing is much easier moving forward. And then, when it comes to VIO, we've done a lot of work. So that's head tracking. We support multiple implementations of head tracking, and it was a really nice experience for us that we had an original head tracking implementation, OpenWinds, and then when we took Chimera and tried to put it on ILLIXR, I think it was Josefa. Of course, Josefa's maybe worth many more people in terms of time, but Josefa was able to do this with some help in a few hours. So that's very exciting to us. And we hope to continue this so that we can do this for other implementations and other components as well. Yeah. Other comments?
Hello, I'm Mateo, also from Collabora. I'm working a bit on SLAM and VIO tracking on Monado, and well, I was talking a bit with the ILLIXR team in Discord. I think it would be pretty cool to develop some kind of common interface in the future to have the same interface that Monado is using for SLAM be shared with ILLIXR. It seems that a lot of the issues you have solved are the same ones I stumbled upon when starting this project. Yeah. So it would be really nice to merge those efforts somehow.
Yes.
Yeah. So yeah, basically, so this was the same problem with applications and at the OpenXR level, right? There's a lot of fragmentation. People were solving the same thing, and then OpenXR came along and standardized those interfaces. But it's not just the interface between the application and the runtime, right? Once you're inside the runtime, there are tons more interfaces, such as you mentioned, right, for SLAM and many other things. And one of our goals is to standardize those as well, because like you said, there's a lot of fragmentation. People develop their things in isolation, and then when you try to plug them in the entire system, it's not always easy.
Yeah.
Yes, indeed. So yeah, I will be hanging around the Discord asking more.
Yeah, please. Yeah.
It's
great to see you. Yeah.
Yeah. And get involved, right? Get involved with the consortium and contribute towards how we should finalize these interfaces, right? So we've done our best effort so far. Yeah. Okay. Other thoughts, comments?
Thank you very much, Sarita and Mohammed, to bring all the researchers all the XR researchers together. My name is Qian Liu, and I'm from University of Texas at San Antonio, and my research is about cloud graphics rendering. So I'm very interested in the computation offloading topic. Yes, and other topic like accelerators, how to build because we have known XR has a lot of different components, and maybe some of them need to do some to build some hardware accelerators to speed up the computation, and some maybe some not. Yeah, some. So as we know, there are several ways to build accelerators. Sometimes we just treat accelerators as a functional unit in the in the computer in the CPU cores as a function, as a functional unit. And another option is to treat the accelerator as a I/O device.
Right.
Yeah, but the I/O device would have longer communication time. Right. If the computation task is too small or fun, for fun computing tasks that may not suitable for the I/O devices as an accelerator.
So we have a lot of work in this area, right? A lot of work.
Yes.
And so look forward to more discussions of these topics, and more. This topic will definitely show up in the meetings. And if you would like to present your work either in the offloading area or the accelerator area, please get in touch with us. There's going to be a talk later on from a group that is looking at doing simulation for XR workloads for to figure out architectures that don't exist yet, right? How do you evaluate those in simulation for such a complex system? So there'll be a talk on this topic in April. I think it's on April 6th. We will have many such discussions.
Okay, thank you. Very great work. Thank you.
Thanks. Thank you.
Thank you.
Other comments? And actually, it would be great if people could, whoever's comfortable, turn their videos on, because we'd like to take a picture of us.
I do also have a small question here.
Yeah, please.
I feel bad even asking this question because I feel like Linux is the way to go. But I actually was looking into OpenXR because of its multi-platform support as well for OSs, and I see the collaborative people are here as well. So I don't know if there's any plan to incorporate some kind of Windows support or anything like that into Menando, but
yeah.
So
we go ahead.
For Monado, we have up and running on Windows. Not all of the components, but it's there. It's not a priority, unfortunately. And if we had more people, we would have it up there. But we're hoping to actually get to it sooner rather than later, to actually make it a proper target, and like actually have a CI running so we don't break it. Stuff like that.
So for us, we do have a serious effort moving this porting to Android for sure. Windows hasn't begun yet, but it is on our bucket list. And again, if you're interested in helping us out with this, let us know, right? So it's all in the open and lots of support from us. But right now we don't. It's a matter of prioritization, right? So if there are a bunch of people wanting Windows that will enable ILLIXR to go further, we will pick that up, right? And that's how we picked up Android, for example.
Awesome.
But I have a question about the Windows system. Because I would know, as we know, it's a closed source system. Sometimes it may be not easy to do system level optimizations.
Yeah. So that is an issue, right? If you want to do scheduling at the level that you want to mess around with the operating system and you can't do it, there's not enough APIs, well, you're stuck, right? So yeah, that is a trade-off. But we're not going to solve the Windows problem. What we are saying is we will port ILLIXR to Windows so others can solve whatever problems are unearthed.
Yes, thank you.
Yeah.
Awesome.
Okay.
Hello.
Yeah.
I have a question. Let me introduce myself. So I'm a PhD student from University of Southern California, working with Professor Ramesh Govindan.
Great.
So my interest is in volumetric video streaming. So the ILLIXR platform is one of the platforms that we are also targeting for our application. So one question I have is that, do you have any experience or any kind of application where you have targeted live streaming? Meaning here, I as far as I've read the paper or I've slowly become familiar with ILLIXR is like the 3D reconstruction application or maybe some other applications. Most of them might be kind of static scenes. So I'm trying to figure out where you can actually stream live point clouds or live captures from other places, but the captures continuously change. Then those systems stress more on networks. And what are your plans for integrating those kind of applications?
Yeah, so this is close to our heart, a project we are doing right now. There are a few students here who are actually working on things like this. Suzefa, maybe you can take this.
Yeah, so I guess we can talk about the proposal as well, right? So one of the applications is definitely 360-degree video streaming. That's what we're starting with. So I understand that volumetric is harder and different than that. But certainly looking at interfaces between the edge device and the cloud is something we're working on right now. And then what are the challenges with volumetric streaming? How do you get the head position? What if the head position moves by the time the packets start arriving? What if you and then of course, how do you tile the videos and what the individual compression and bitrate for the tile should be? So yeah, that's something we're very much interested in. There's a professor here, Clara Narstedt, who works in this domain, and we have been looking to start a collaboration with her to work on exactly this problem.
And your advisor too. So yeah, so a lot of this is research, right? So as the research happens, it will get integrated back into ILLIXR. But we do have volumetric rendering and things related to that on device already functioning. Yeah, the streaming part is what is ongoing future work.
Right. Okay. Thanks a lot.
Yeah. No, I look forward to your work and hopefully you will contribute back here so that others can build on your work.
Yeah, so great work. So I was always trying to find out some kind of platform where this kind of applications sit. So I think ILLIXR is one of the platforms which is very suited for my application as well.
Right.
So hoping to contribute as well.
Yeah.
Thanks a lot.
Yeah.
Thank you.
Yeah. Great. Thank you. All right. Anyone else want to chime in?
One question, and this is from the research angle. Like I did my research, my PhD in a networking research group. So, and it was joined with the Nokia Bell Labs. So mobility management, it often used to come, like especially in the future, like in 5 years, will we be able to make holographic calls in the wild? So when I was doing my intern at Bell Labs, we were able to do this in a laboratory setting. But in the wild, like the way we are doing this phone network while we are in the train, high-speed train, can we do that like holographic calls? So our conclusion, at least my conclusion during the internship, was that probably we cannot rely only on the hardware. We will have to optimize the entire pipeline actually.
Yeah.
So basically optimization right at the human level. For example, one of the slides you mentioned, there was a photic rendering, like keeping track based on the eye. And the information which is further away from the eye, we can reduce the resolution of those parts.
Exactly. Yeah.
So we need to optimize the entire part. So I was wondering, are you guys looking into sort of, working more from the mobility management as well, like in the wide, like this?
Yeah. So there's mobility, and then but the point that you mentioned, the whole idea of having an end-to-end system, so that you can bring in all of these aspects, right? So the foveated rendering work that we're doing is along with eye tracking, but in terms of user perception metrics, and again, you're part of the perception lab effort there, right? So how do you evaluate the goodness of the system? There are metrics out there, but there's still room for improvement. So we'd love to get connected to folks who are doing that work. And now we have a platform that is open, and you can do these measurements, and not only do the measurements, but then see how the system can respond to those metrics and have a proper loop going on, right? That was not possible before in open research. So, I did briefly see someone from Toby here. So there's lots of conversations to be had about open infrastructure for eye tracking research that can feed into the system. But that's part of our agenda, and again, would love to see you contribute. And there's a lot of this is really cutting edge research, which we appreciate will happen in individual labs. But what we hope will happen with ILLIXR is that the path for that research to come out in the open in a common system, is much faster now, right? So that's the hope, and so people can start building on each other's work.
So one more question. Sorry for interrupting again. Do you have any experience on machine learning based models for maybe some kind of application that fits on top of ILLIXR? And what are thoughts on those?
So for example, our eye tracking component uses a neural network.
Okay. And then some of the classical ones we're actually trying to migrate. So holography is a classical algorithm right now, but the neural approaches are better. So we want to try those as well. And then certainly for scene understanding, which will take the input from scene reconstruction, that's almost all machine learning.
Yeah.
Right. So, but the one problem where this kind of so at scale, if we want to build this kind of machine learning based models, then comes like GPU scheduling, or how the workflow can be scheduled on some level collection of GPUs.
Yeah, so shared resources, right? And everybody wants the same resource and at different times and for different lengths of time. So figuring out those schedules is definitely something we're interested in. I think a lot of people are interested in.
So the point is, there's so much research. As we said, we view ILLIXR as a really rich playground for systems research, right? So now you have a platform, right? So use it for your research, contribute back to it as your research gets mature, and let's democratize this research and development in this area. That's what we're trying to do. So I'm mindful of the time. We have, Josefa and I, and will be around. So we are happy to continue chatting. But I do want to make sure that the official part, we have just 2 minutes left, and so if anyone has kind of burning questions about the consortium or.
So I see 2 raised hands. I think Armand raised first.
Okay.
Hi, my name is Armand. I'm from the University of Michigan. And I guess I just wanted to ask what's, the best value way that, a student could contribute. Would that be like, doing my research and then, later trying to integrate it in or open sourcing it, or what provides value to you guys?
Yeah, so don't think about it as value to us guys, right? It's value to the community, right? So now the consortium is really a community thing, and so use ILLIXR, do things in the open. We are big proponents of open work, right? as you get your results, try and contribute back. But more important, stay involved, right? Attend our meetings so you stay involved, you contribute, and volunteer to form working groups, right? So if there's something that's really bothering you in your work that you're not able to make happen, here's a resource, right? Where you can come in and say, hey, give a presentation in one of these meetings, right? They're going to be informal meetings. Give a presentation and say, hey, I'd like to get a group of people to think about how to get all of these VIO algorithms into an end-to-end system, right? Shall we just work together to do this rather than each of us reinventing the wheel, right? So we've done a lot, right? It took a lot of work for this group. So it would be great if people who are trying to solve the same problems, and many are, right? If we can do that out in the open together.
Yeah, and just don't hesitate to open issues on GitHub, just to say this is something that you would like to see, and then we can say, oh, we are working on it, or you could say, I would like to work on it, and then we can assign that task to you, so there's no duplication of work. And in terms of incorporating research back into the testbed, yeah, just do your own thing, and then once it's done, it's in a reasonable state, just open a PR and contribute to ILLIXR. That's actually how our internal development progresses as well. We develop components and prototype things just locally, and then at some point we open a PR, push up the commits, gets tested, and gets merged in.
Yeah, and we welcome your thoughts as well as to how we can make this more effective. Okay, I guess Mike.
Hi, my name's Mike Buford. I kind of came in through the North Star group where I'm building my headset. I'm primarily a security engineer, and I'm kind of curious. It sounds like you guys haven't talked about that yet, and I was kind of curious.
Yeah.
If that's on your roadmap or radar.
Yeah, I know there's one person here who has been looking at security using ILLIXR in the group. I don't know if he's still around. Kaiman, are you here? No, I think he dropped off. But definitely on our roadmap, we did we take it off the slide, Huzefa? I don't remember. It used to be on our slides. So we haven't done any work on it yet, but it's a huge part of our roadmap. I mean, we just, we'd love for people to look at security issues and privacy issues in this space. Use ILLIXR for that. We have one group who's looking into that, but this is just starting.
Yeah, because it was a big hole I saw, and I was just wondering. I know you guys are just trying to. You got to stand before you walk before you run. But there's whole sorts of security, privacy issues.
Yeah, no, absolutely, yeah.
Okay.
But thank you for bringing this up. We will put that term back in so people don't think that.
And then it's Franziska Rosner at University of Washington. She's also part of our advisory board, and she's looking at augmented reality security and privacy issues. And,
awesome. Okay, cool.
Yeah, something very much interested in.
Yeah, and we plan a talk on those issues in subsequent weeks soon.
Okay, awesome. Thank you.
Great. Other questions?
Zishen has a hand raised.
Hi, my name is Zishen, a PhD student from Georgia Tech, working with Professor Vijay Rochatori. Actually, I have the same question as the Mike, because I was trying to ask, do you consider the reliabilities? So apart from security, also the reliability is a big issue, I think, for the AR/VR and also the autonomous systems. Because I know your group has a very great work on the reliabilities, like soft errors, hard errors before. So I was wondering, do you think the reliability is also important issue?
Absolutely. Absolutely. Yes, absolutely. We do have an effort in that, and we try to keep the points on the slide. Slide is labeled ongoing research, and we try to restrict it to things that we are really very actively doing, and there's sort of papers on the horizon kind of work. But yeah, definitely reliability and security and privacy are as you pointed out, we do a lot of work on reliability, and in fact one of the students who's working on that is here. And if you'd like to contribute or again give a talk in the area, let us know and we can discuss what could be done.
Sure. Yeah, thanks. And also, I think I'm also interested in like build some accelerator, like hardware accelerator at the digital mixed signal. We're using some of the like computing memory with the new laboratory memory to accelerate these AR/VR applications.
Exactly. No, we hope that there'll be a lot of talks and discussion about how to use accelerators. As you saw on the list, this is something we do a lot. There are issues about how do you run a simulator with such a complex. Of course, you can take each component standalone and simulate it. I mean, that's not a problem. But to really exploit ILLIXR and do the end-to-end, again, we hope that this group who will give a talk, the group is from Berkeley, they'll be giving a talk in April. We hope that will, propel some more research in this area.
Yeah, fantastic. Yeah, thanks.
Other comments, thoughts? Okay, well, yeah, was there someone?
Kwanlin.
Hi, yes. My name is Kwanlin. I'm from Colombia. I'm working with Professor Luca Caroni. So I'm just, I think I got my question answered. I was curious about how, if you guys have done any hardware accelerator for the ILLIXR.
Actually with Luca, with your advisor. So the 3D audio, the spatial audio that we have, that's been we have so in a collaboration, not only do we have an accelerator, but also taped out a chip recently. So Luca and we are part of another project, and Luca and collaborators from Harvard and IBM, work to, so there's a big chip with many accelerators. It's a full heterogeneous domain specific system on chip. And it'll be exciting when the chip comes back. Yeah, and we'd love to, in fact, I know you work on the ESP team, so this is something that's very much part of our research agenda, is to get a lot of ILLIXR accelerated and integrated into the ESP platform.
Yeah, thank you.
Yeah, great. Other comments? Okay, so let's see. So I guess so we will wrap up this meeting, and I hope to see many of you next week. Again,
all of you, hopefully.
All of you,
and
your
more.
friends, and your friends.
Yep.
That's right. And please reach out to us. You can use our individual emails, or illixr@cs.illinois.edu is a great way, or for public comments, our Discord channel as well.
And then all of these are on illixr.org if you can't remember them off the top of your head. And as a reminder, next week will be distributed XR and how that will integrate with ILLIXR.
Yep. Yeah.
Thank you.
Okay, so Josefa and I will stand, hang out if you have anything to discuss in a smaller group.
Thank you for coming, everyone.